All right, we have example 1 here, looking at domain and range. So example 1 is giving us an equation. So we have to look at this equation and figure out what the x values are and what the y values are that exist here. So I'm going to use my calculator, and I'm just going to jot down. I'm going to use the calc to get a visual. It might be there might be a clear ending point or a clear starting point in some of those. So pulling out my calculator, jumping to y equals, clearing out whatever was in there from before. We have x squared minus 2, second in table, which I really didn't need to go to, but I could have just went to graph. Okay, so I can see here based on my graph that the y value, because remember y goes to the sky, so y is up and down. And actually I'm just going to draw a little bit of a visual here because it helps. That y value right there is -2. So I'm going to make a point right there and -2, and my graph goes something like that, more or less. And I can play with the zoom and see for sure. If you're not convinced that it keeps going, you can just play with the zoom a little bit and just see what happens as you keep zooming. Oh, there it goes. See? And you can keep zooming and zooming, and you're seeing it's just kind of getting further and further out. So again, just a little zoom lesson. You can go back to zoom 6 to get to zoom standard. So the important thing about these kind of, what these are actually called parabolas, we'll get to that eventually, hopefully. The thing about parabolas is that they don't just keep going up, because if they did just keep going up, they would be vertical lines, which are not functions. So these things also get wider as they get taller. So I'm just going to make a note of that. This gets wider as it gets taller. It's called a fancy new word, parabola. Parabola is how it's spelled, but it's pronounced parabola. Okay, so looking at my domain and range here, I'm going to start off with domain for my x values. So as we talked about, the parabola continually gets wider and wider and wider. So there's really not ever an x value that it's not going to reach. It's going to hit all of the x values going from left to right. So domain in this situation is -infinity all the way to +infinity. And I cannot put a finger on either infinity going in either direction. So I have to be using the parentheses because that means not included. Writing that the same way, but using inequality notation, it's not included, so I'm going to be using the less than symbol. And you're really not ever going to be using the greater than ones. You're only ever going to be using the less than ones because that's what makes sense in the sentence. So domain is x, so we're starting -infinity is less than x, and x is less than infinity. Neither of those are included because you can't put a point on infinity. Now it's the range that gets a little interesting here because the range is different. Our range, there are y values, and I'm just gonna, this is x, this is y. There are y values that this graph doesn't touch, right? This graph does not exist down here. The graph does not exist down here. Like there's no graph there, there's no y values there. So we do have a minimum y value. The y's do not go lower than -2, so that's what we're going to be starting with. So our range goes from -2, and that's included because there's not an open circle. You would clearly be able to see if there were open circles. But there is no y value that it stops at though. So it is going all the way to infinity, which gets the parentheses, not the bracket. Now for range, -2 is included, so it gets the or equal to. Range is y, so don't forget to change your variable. Infinity is not included, so it does not get the line under it. And there is our domain and range for example number 1.